Brian, do we get a break?
That's up to Charlie, who is now the moderator.
Yeah, sure. Why don't we at least take is 5 minutes enough?
No, one backwards.
All right, 10-minute break. And then we'll come back in and get started with the grad presentations. All right, I think we are approaching the time. I'm going to go ahead and share my key slides, which are not as fancy as Brian. Brian showed me up today for sure. And we'll get started. Make sure I share the sound. Cool. So that is not the first one up. The first one up for Kai and CC and Zhang with Meng live coding worlds, and I still don't know. I just learned the title of it yesterday, so I don't know if I'm pronouncing it right yet. But I think they're going to explain it a little bit. And so we have four presentations done via video, and 2 presentations that are going to be done live. And so we should wrap up around 4:45 or so.
Hi everyone, this is Chunzhen Jiang.
Hi, this is Kai.
This is Jian.
We are happy to be here sharing our master thesis project, Meng. In Chinese, Meng means dream. We hope users can build their dream world with our system.
Traditional network coding systems are browser-based platforms using keyboard input to create an interactive experience. As to VR, most of prior research on programming in VR environments also focused on creating virtual keyboards. We believe that trying to bring traditional programming interfaces like keyboards into VR is the wrong approach. Instead, we hypothesize that programming in VR can take better advantage of the medium through the use of voice commands and embodied gestures. In order to reach our goal, we carried out further research in the following directions. This is the overall architecture of Meng. Firstly, we brought the Sphinx UE4 plugin into Meng for users to input their voice commands. By taking advantage of the grammar mode and the flexible just-speech grammar format, we allow users to input more complex and natural statements. The picture on the right is a user creating a red cube by just simply saying new red cube. As for Sphinx, only words on the word list can be recognized. Luckily, Google Speech-to-Text has amazing accuracy when recognizing natural speech, but it takes about 3 seconds before returning the result. By combining them, Meng can react to short commands immediately using Sphinx, and process natural speech such as tagging and query using Google Speech-to-Text. For example, users can query and select all mesh-based agents, then change their color to red. With Unreal Engine VR plugin, now Meng enables users to draw arbitrary paths for objects to follow, and the controllers can stretch those paths and change their scale. The GUI system should supplement the voice and gesture input, so we kept it as simple as possible. Otherwise, it will affect the user's immersive experience. This is our demo video.
Shape to sphere, shape to box, color to red, color to blue, and bigger, bigger, and smaller, smaller. Very, very much.
For content creation, we apply procedure shape generation with rematching technique that is now commonly used in virtual reality. Rematching enables us to combine geometries in novel ways and create forms like fractal geometries and area fog that are impossible using more traditional rendering technique. For the purpose of using Unreal Engine for building lighting system, we were not doing full-screen rematching as the traditional method. Actually, we do rematching in the local space of each meshes for the better performance. We support creating several types of shapes as the picture on the left showing, and the picture on the right is showing that the effect of area fog we implemented by using rematching technique with the volumetric rendering plugin in Unreal Engine 4. These pictures are the metal ball fractals with different parameters, which are also achieved by using rematching technique. We also implemented 3 Boolean operations for combining 2 geometries. They correspond to the 3 basic Boolean operations, which are union, subtraction, and the intersection. Here is the rendering results. These pictures are showing that we are using Boolean operation between side distance functions to achieve parameter combination and blending. We introduced voice algorithm to simulate flocking behavior for agents. We use a technology called GPGPU to run voice algorithm on the GPU side. That is better at doing parallel computing using Compute Shader. We dispatch Compute Shader every frame and use it to calculate position and velocity for every agent. We are able to run flocking simulation for thousands of agents on the screen at the same time with this GPGPU method.
COVID-19 changed our planned evaluation, as it was no longer safe to conduct in-person user study on shared VR equipment. So to conduct our evaluation, we ported our projects from running on VR hardware to running on more standard PC hardware. Except for using VR control devices to draw paths, we return almost all system features to ensure the effectiveness of evaluation. To help users get familiar with Mon quickly, we created a tutorial which includes 3 parts. The first and the second part aims to teach participants how to interact with the environment with the new input mechanisms. And the third part is a mini task that requires them to choose using GUI or voice commands to create an object without tips. To obtain information so that we can improve the design of Mon, we ask users to complete a survey containing questions about their experiences. In the total, we received 19 replies. About 80% of these tried to experiment with other ideas that were not covered in the task. See figure on the left, which means most of participants could even infer the rest of the corresponding commands by just learning some of them. Except for 7 participants who didn't get to the third part. We knew that more than half participants could finish the third part without using tips in figure on the right. All of this indicate that learning how to interact with the environment in our project isn't too hard. Although many participants could complain in the survey about the recognition rates of the voice input system, they still showed high acceptance of this new input mechanism. As expected, most of participants were quite satisfied with combining voice and GUI to be the main input mechanisms. In this part, we compare Mon with LiveCode Lab, a web-based live coding system we have mentioned in the background section. Cognitive dimensions of notation framework is a common framework in the psychology of the programming community. The whole framework has 13 dimensions, but we only choose progressive evaluation, consistency, viscosity, and premature commitment, these 4 dimensions as the judging criteria. The comparing results demonstrate that the new interactive methods provided by Mon can meet the needs of live coding. Moreover, because of the combination of interactive ways compared to live code-led, it is more convenient for users to interact with this environment. And the more intuitive presentation way not only gives them a better visual effect, but also helps them to improve their works more easily. For providing more intuitive interaction ways in VR, we introduced voice and gesture recognition combining with the GUI system to the project. Different from web-based live coding environments, Mon has better visual effects, and with an additional dimension, Mon provides high degree of freedom exploration which can increase users' creativity. We've made some of our works as open source libraries. Here are the GitHub links. Thanks for watching.
Thank you.
Thank you.
Thank you. Questions for Kai and Cici and Xiang?
Hi, it's Jennifer. I have questions. I have a question. I was super interested to see the interface that you created for the live coding. And I'm wondering, as we move more and more into these three-dimensional simulated spaces, for most of our computerized mediation, is there anything that you learned from doing this in terms of the human-computer interface user experience from live coding that might inform other ways that we can think about information in three-dimensional space?
Yeah, so when designing Mon, we are learning some from the CDN, and it teaches us how to create a language also with the interfaces. So.
And we learn a lot about how to design an UI system in the virtual reality. And so we attach our user interface on the left controller when you are in the virtual world. So you actually can rotate the UI interface. I think compared to you put the UI interface on the screen, attach it on the as a 3D model in the scene is better. Yeah.
Does your report explain in detail how you managed to get around the latency problem with Google Voice? I was very intrigued by that.
Actually, it depends on your how long your speech is, and Google recommends the smaller data that your speech is, the faster the response is. So Google recommends users to have one sound channel and 1.6 kHz sample rate. So this is enough for the speech recognition, and the speech data is pretty small, so it can only takes 2 or 3 seconds for your short commands. The
right,
latency.
But in your demo, it was responding instantly.
That is, we combined Sphinx and Google speech to text. We react to short commands using grammar mode of Sphinx. Sphinx is a local speech recognition engine run on your computer, not on the cloud.
I see. Okay, so you're combining you're combining. It's a hybrid. It's doing some local and some
Yeah,
on the cloud. Okay.
Because Sphinx, the natural speech mode of Sphinx, the accuracy is pretty low. So we combine the Sphinx and Google speech to text.
I understand.
And the grammar mode of Sphinx can only recognize the word on the word list. It's not a very free. You cannot speak freely.
Right.
Yeah.
So if the user can be trained to speak in the imperative simple language, it's fast. This is what we did at Infocom back in the day. We trained people. We trained people to speak in Infocom English.
Yeah. Cool. Thank you very much, and congratulations again to the three of you. And we got to move on to the next one. So this will be Nick and Zinzin.
Hello, my name is Nick Parker, and together with my partner Zinzin Kyan, we will be showing you our thesis project, Code Smasher. Before even beginning this project, we had a solid experience goal, which was to provide interesting and engaging way for players to learn about a historical figure. As such, we developed Code Smasher. Code Smasher is a code-breaking puzzle game developed for the PC using Unity that explores the life of Elizabeth Smith Friedman, America's first female cryptanalyst. And it should be noted that Elizabeth spelt with an E is not a typo. This game follows her career using two different ciphers to represent different times of her life, one being the Bacon cipher from the years of 1916 to 1920, and Substitution Cipher from 1923 to 1931. Before we began developing the game, we obviously needed to research Elizabeth herself. She began her cryptology career in 1916. As a Shakespeare enthusiast, she had traveled to Chicago to see Shakespeare's first folio, which was being held at a library there. While she was there, she was invited by a textile baron by the name of George Fabian to Riverside Laboratories, a private think tank of his. While she was there, she was asked to work on the Baconian Shakespeare theory by solving codes in Shakespeare's writing. This theory perpetuates that Shakespeare was in fact Sir Francis Bacon, who was using the name Shakespeare to write his plays. She eventually, over the course of working at Riverside, began working with U.S. governments on a number of military ciphers. Also, while she was there, she met her husband, William F. Friedman. She worked at Riverside until 1921, at which point herself and William transferred to the War Department in Washington, D.C., where they solved a number of ciphers used by anti-prohibition smugglers. During her time in D.C., from the years of 1927 to 1939, she worked with several government agencies. She solved over 12,000 rum runner messages using at least 24 different coding systems. Her work led to the conviction of the infamous Ezra brothers and the indictment of Al Capone. During World War II, she was transferred to the Navy, where she decoded over 4,000 German spy messages sent on 48 different radio circuits, and included in those are 3 separate Enigma machines. After she retired, Elizabeth and William wrote a manuscript debunking the Shakespeare-Bacon theory, and following William's death in 1969, she compiled a library and bibliography of his work, which is currently being lodged at the George C. Marshall Research Library in Lexington, Virginia. After Elizabeth passed, the library also added her work to this bibliography. After we had completed researching Elizabeth, we needed to research a number of different games to gather inspiration and get ideas of how others have made games similar to this. We researched a number of different games on the PC and on mobile devices that we drew inspiration from, and through this research we gathered a number of bits of knowledge and examples of how to scale coding difficulties, how to develop our user interface, and what music to add. After we had completed that research, we obviously needed to then look into the ciphers themselves. The first cipher is the Bacon cipher. As mentioned before, it was created by Sir Francis Bacon in 1605, and it encodes a message in the presentation of text rather than the context. In order to use it, it replaces each letter with a group of 5 A's or B's, based on a special alphabet, which you can see on the right. The encoded message uses 2 different typefaces to represent each letter. An example, bolded and non-bolded letters, which we used in our game. The decoding process is the same in reverse. And you can see an example here where you have bolded and non-bolded letters represented by A's and B's. Decoded, it spells the word bacon. Next, we have the substitution cipher. This is a relatively simple cipher, but it has many different variations. For our purposes, we use simple substitution, also known as the Caesar cipher, as it was developed by Julius Caesar. Each letter in the plain text is represented by a letter shifted down the alphabet a number of spaces. An example is seen here with a left shift by 3, making A equal X, B equal Y, C equal Z, and so on. Another example below this alphabet, you can see the message, "The quick brown fox jumps over the lazy dog," with the ciphertext using that table above, jumbling it.
For the experience design, our target audience are those who are above 18, but there's no reason younger, interested people wouldn't be able to play. Fans of puzzle games, people interested in cryptography, and those who wish to learn about important female figures of U.S. history. The main experience goal of our game, Code Smasher, is to allow players to discover Elizabeth Smith Freeman's story and the history of decoding through decrypting and solving cipher messages, not only to learn about her life, but also know how hard her work was by experiencing it.
For our art design, we wanted to represent the time period that Elizabeth was working in. As such, we chose to simulate what looks like typewriter writing on old paper. For our interface, we took inspiration from the games Cipher and Cryptogram, and for our cutscenes, we gave them a sort of scrapbook-like visual. The buttons were all designed to resemble typewriter keys, and the font resembles typewriter font.
For the UI design, to improve the user experience, the interface of the game changed a lot from the paper prototype based on the results of playtesting. More functional buttons and detailed tutorials are used to help players solve those ciphers in an easier way. For the substitution cipher, the cipher text and answer panel are combined together, and the frequency analysis panel is added to help players know the frequency of each letter. For the technical design, first of all cipher text in Code Smasher is generated from plain text automatically so that it is expandable. For Bacon cipher, we first transform the plain text into AB string and make it the same length of written text so that we can save it directly as a stamped answer. Then spaces will be inserted into the AB string as they are in the written text. Finally, we inserted border characters as B's in the plain text to make up the cipher message using rich text function in Unity. For substitution cipher, a dictionary of how they are substituted is made by the alphabet and a randomly shifted string of it. Prefabs are used to set the cipher text after transforming. Another dictionary for the answer will be filled in, and every other prefab that has the same cipher data will automatically fill in after typing in one of the prefab. For assessment, in conclusion, players are satisfied with our game in both story and decoding. Over 90% of the playtesters saw the story part of Code Smasher is clear enough to understand. Most testers told us they actually enjoy the story. Most tests over code system are trying to balance the difficulty of each cipher. Although most of the testers got stuck somewhere during the game, still over 80% of the testers have completed the whole game. Most of the testers agree that the difficulty level of Bacon cipher is above 3. Like at the middle of the table, 50% of the testers who didn't complete stopped at transforming text into A's and B's, which is because of the font we choose. For the substitution cipher, most players thought it was quite difficult, yet not unable to solve. And the hardest part for them was to decode the cipher.
In conclusion, we've decided that our game is a fun way to tell a story, but not necessarily a fun game itself. The majority of our players enjoyed learning about Elizabeth, but had difficulty with the code breaking. However, that was the point. From the beginning, we wanted to show how difficult Elizabeth's work was and how skilled she was to complete it all with pencil and paper, whereas the players had a computer and a system designed to give them hints. In the future, we hope to continue refining the user interface and player interaction. We also hope to reach out to the George C. Marshall Research Library, where the bibliography of the Friedman's work is being kept, to possibly establish a connection between our game and Elizabeth's physical body of work. In the end, we hope that our game gave a better appreciation of Elizabeth's work and the work of codebreakers around the world. Thank you.
Yay, awesome. Any questions for the Codebreakers team? Smasher.
I just want to say that I'm delighted to see Elizabeth Friedman being noticed this way. I hold in my hand my first edition of the Shakespearean Ciphers Examined by Elizabeth and her husband, published in Cambridge in 1958. It's just about the funniest book you'll ever read. They demolished the Shakespeare ciphers pretty thoroughly, but she and her husband contributed arguably as much to saving civilization as the fellows in London did. She was a hero, a heroine, very much so.
Eric, did you have a question?
I did. So first off, fantastic job. This is a really cool project. I was wondering if y'all wanted to comment on solutions that you found for paper prototyping under the current like social distancing conditions. I don't know if you guys had to like prototype remotely, or if you guys had to, or if you guys had the ability to do things locally. So I was wondering if you want to comment on that.
Yeah, we did have to. I think our original first paper prototype was before COVID, but after that, it was all remote. Zinzin, do you want to expand on that?
Like we first made our paper prototype, and we based on the version we made the first digital prototype, and that is not shown on the presentation. It's actually very similar to it.
Okay.
And we test a little bit on that version on AlphaFizz, I think, and we get feedbacks and we try to fix questions on.
Fair enough. Fair enough.
Basically, Zinzin kind of built out a paper prototype and then just sent me a bunch of pictures, and then we tweaked it and changed it how as much as we needed to.
That sounds about right. This has been a fun time overall, this whole building games in a pandemic.
Yeah,
so
sure. Definitely
always interested to see the solutions people have come up with.
Definitely, that's some like serious air quotes around fun there. I think you need, yeah. Any other questions? I know I just wanted to briefly say that I thought the evaluation results were really compelling. That both like the distribution of like how difficult people thought things were, and the fact that you managed to make what I assume was like the final cipher, difficult enough that everybody graded it at a 5 out of 6, but still 80% of the people finished your game. I thought that was really fantastic.
And I think a part of the reason is that we help them through the game.
Okay.
Yeah, that was part of it. In a lot of our playtesting, the players got stuck, and I think.
Okay.
But I do think part of it was. I do think part of it was a lot of our testers weren't native English speakers, so we had to help them out a little bit along the way. But yeah.
Any final comments or questions?
I solved them. I did it.
You did do it, Dean. Yes.
I think I managed to do it during alpha. I can't remember if I needed a hint or not.
Let the alpha version.
I'll try again.
Yeah.
Yeah. All right. Next up is Eric, and Eric is going to be presenting live. So let me make him a co-host.
Yeah, we're here to have a good time, share things live. Hope nothing goes wrong.
It seems appropriate for your project.
Yeah.
Yeah.
I did a lot of Zoom stuff, so hopefully I can use Zoom more.
Oh, Brian already set it up so everybody can share. I don't need to do anything.
Oh yeah, okay.
Even better.
Awesome.
Go for it.
So yeah, my name is Eric Cerny. I'm here to present on my thesis project, the USS Cape. I built an escape room in a pandemic. So first off, I just want to start off by saying that this project could not have been completed without the help of the wonderful team of graduate and undergraduate students that I've recruited, as well as my fantastic advisor, Dean O'Donnell, and my readers, Brian Moriarty and Joshua Rosenstock. So yeah, I'm going to start everything off with a video to show you guys how this all works.
Greetings, Mission Control Operator. Insert name here. Welcome aboard the USS Cape. I am the Super Universal Subspace Actuation Nucleus, but you can call me Susan. I monitor everything aboard the USS Cape to ensure the crew has a comfortable and safe ride home from Mars. Status report. The crew seems to be trapped in various rooms throughout the ship.
We got a lot of information for us to sort through for a second.
Current trajectory shows the ship will be trapped in the sun's gravitational pull in 15 minutes. Requesting you and your team of up to 7 other operators to assist the crew members and help them escape so they can correct the ship's course. We are counting on you. It'll be nice to meet you.
Oh, I am apparently playing it again. Please let me move to the next slide. Thank you. Okay, so what you just saw is the USS Cape. It's an escape experience that's designed to be played virtually. You and your teammates in Mission Control need to work together with the crew members aboard the ship in order to correct their course and provide them safe passage home from their Mars expedition. For a bit of context, an escape room is a game where the players are put in some unfortunate situation and they have a limited amount of time to resolve it. This resolution typically comes in the form of escaping a room, and the method of resolution is typically finding clues and solving puzzles. Escape rooms started as virtual experiences when Toshimitsu Takagi created the Crimson Room back in 2004. This sparked the creation of a whole genre of games called Takagisms, where developers would make similar point-and-click adventures where your goal was to find your way out of a locked room. Soon after, the genre took physical form when the company Scrap made the first live-action escape game. Now, there are escape rooms all throughout the world, and they're frequently used for team-building events, birthday parties, you name it. All of this is to say that with the social distancing mandates brought on by the COVID-19 pandemic, a lot of these physical escape rooms have had to adopt new technologies to deliver their rooms to players, creating an interesting new design space of hybrid physical and virtual escape rooms. The most common adaptation involved sending an avatar into the room, hooked up to a body camera to act as the player's eyes, ears, arms, hands, legs, and whatever else while they're in the room. The players can tell the avatar to look at and explore different aspects of the room in an effort to gather more information, but they're ultimately locked to that avatar. So we had 3 primary design points that we wanted to address when designing the room. The first was collaboration. Escape rooms are all about team building and working together, and we wanted to make sure that players had the tools to share information with each other and work together on puzzles. We also wanted to facilitate collaboration with the actors because they're a resource that we have to enhance the experience. So we wanted to use them to the best of our ability. Second, engagement. We found that with the escape rooms that we did, it was easy for someone to feel like they weren't contributing since there's only one thing that the group can look at any given time. In addition, since they were adaptations of physical rooms, there were certain puzzles that had the players perform some cool action that we just wound up watching the avatars do. For example, one room that we did required us to get a cork out of a bottle using a rag. So we told the actor to do that. And the game master was like, okay, while they're doing that, why don't you think about a different puzzle? Which felt really bad for the experience. With this in mind, we determined that all cool things or interesting actions should be done by the players. Third, exploration. An important part of an escape room, for me at least, is being able to go off and do your own thing or split into small groups and have everybody work on multiple puzzles at the same time. Finding puzzles is just as fun as solving them. So ultimately, we chose Zoom. It's not the most novel choice, I know, but the features that it provides were too useful for our design pillars to pass up. Video chat was important for engagement. Screen share was an important collaboration tool for players. But the most important aspect of Zoom was the breakout rooms. We knew we wanted to use these immediately just because of how well they line up with that exploration pillar. We were able to create 3 separate distinct rooms that players could freely switch between to make it feel like they were actually moving about the ship. It also allowed for multiple smaller groups to be working on puzzles without having to talk over each other. Alongside our video call, we needed some way to serve the puzzles to the user. After seeing how other virtual escape rooms passed information to the users, we decided that a companion app would be a great addition to our experience. The tracker includes several features that assist in facilitation and encourage interaction between the players. The 2 most prominent features are the timer in the top right, which helps to inform the players of how much time they have left, and the viewport in the center of the screen, which we use to serve files and puzzles and executables. So in that viewport, we serve the players information in the form of 4 different file types: images, PDFs, videos, and executables, as we called them. The first 3 are self-explanatory. We had some puzzles that required us to serve static, non-interactive files to the player, but the last category, the executables, made use of embedded JavaScript applets through the Perl and Spiel engine. That enabled the player to do those cool things that we were talking about before. In this screen here, we've asked the players to help our good friend Faith Pickles resolve some issues with the bathroom piping. Players can click the elements in this grid in order to interact with them and solve the puzzles, and players can switch the current file shown in the viewport with the sorted list to the left. There are 2 other features that you'll notice that we added for collaboration. We have the color tagging system in the top, which allows players to assign their own color coding to the file system and more easily notate clues that they've used, and the notes box below the viewport, where players can type information that they've gathered about each clue and share that with the rest of the crew. So the way that we achieved this tracker is by using Node.js to host 2 different servers. We had an Express server that served our React app, and a Socket server that managed all of the connected users and sent updates to their system whenever we needed to push a new file out to the player, or a player made a note, or they changed the color of a file, or really anything about their game state updated. So takeaways. During our limited run of this room, we had 2 interesting takeaways regarding the experience. The first involved how well certain types translated across this medium. One of the primary thoughts on puzzle design that I learned from Dean is that you can define most puzzles by 3 factors: discoverability, which is how difficult the puzzle is to find; interpretation, which is once you found the puzzle, how difficult it is to determine what you need to do; and execution, which is after you've determined what you need to do, how difficult is it to do that thing. So after our show weekend, we rated each puzzle on a scale of 1 to 5 for each of these factors. We compared this to the responses received from 18 playtesters on their level of enjoyment in solving each of the outlined puzzles. And it's worth noting that this sample size is not large enough to draw significant conclusions, but there was an interesting early trend. So when determining a line of best fit for each of these scatter plots, it was noticed that the only one that had a negative slope was the plot for discoverability puzzles. This indicated that the puzzles that we rated as more discovery heavy were considered less fun by our playtesters. Potential reasoning for this is that typically in escape room, these puzzles involve looking around a physical space to find random bits and bobs or sigils on walls or something, and then doing something with those. We tried to emulate that in a few places in our room. Specifically, the bathroom was where we had most of those discoverability puzzles. But without that physical exploration, it seemed that these puzzles didn't really have that same impact. The other takeaway was that the players seemed to really enjoy the fact that there were actors to help immerse them in the story. Unpromptedly, almost half of our playtesters made comments on how the actors enhanced the experience. From a facilitation standpoint, having actors in the room allowed us to control the flow and pacing of the game. And if players were struggling too much with a puzzle or misunderstanding aspects of the room, the actors could guide them with comments like, yeah, there's a 4-digit number pad in my room. Any thoughts on what we could put in it? Or I'm pretty sure the manual said there was a reset key. Yes, you can reset the engine override by pressing the R key. Peppering in these comments along with casual interactions with the players allowed us to have more than a few exciting conclusions, where players were rushing to the finish line within the last minute of the room, ultimately increasing the tension and release that they felt and creating a more satisfying resolution. So thank you. If you're interested in trying it out, reach out. In the past, I've given this presentation a couple times, and in the past, I've offered to host rooms and nobody really took me up on it. So if you want to try it out, feel free to email me. If there's enough interest, I'll open up some slots. I'll open up for questions here, but if you have any that you don't feel like discussing on this call, feel free to email me directly. But yeah, go ahead.
Yay.
Want to play the game again?
I know. I just remembered how much fun it was.
I appreciate that.
I feel like there's going to be a lot of positive, happy thoughts. So I'll get some like negative criticism in there to start thing. No, I'm just kidding. I have none. It was awesome. But I was super curious to hear if you'd continue developing it since we were playing it. I think it was before Christmas. I don't know if you've had a chance to make changes.
I haven't really had a chance to make any updates. I know that you suggested switching over to WebRTC instead of Zoom, which that is definitely in my paper as future work. But unfortunately, a lot of focus on the paper has sort of shifted my attention away from making improvements on the room itself.
Cool.
I have a couple of questions. In terms of using actors, so I guess one of my thoughts are with the idea of the metaverse being developed or anything like that. Do you see possibly like becoming a job creator with this, where you have people who like will just go on for 2 hours a day to be actors for 2 or 3 different groups? Do you see it almost being like a dungeon master going forward? In a strange way, like, and then how do you see like the ideas of avatars playing more into what you're working with? Like, so I guess that's it. Like, how digital can this thing like really get?
Yeah, so this is a fantastic question. I have had people come up to me and say, hey, you should really record all of the actors' parts and package it up and put it on Steam, because this is like a really cool experience in general. And like, I feel like you don't really need the actors there, but like they help enhance the experience. I feel like with regards to that, I liked having the physical actors in the space. I think that having the ability to respond to what the players were saying added to the experience. And I don't know if I had the specific quote on this slide, but there was one place tester that specifically commented on the fact that they responded to their jokes and comments and sort of incorporated that into the room. So I would like to see it more as like a dungeon master role, and I would like to see it sort of take that form, and I want to see if this implementation of actors would work as well in a physical space. I know that there are sort of actor facilitated experiences like 5-wits that exist, but I'd be curious to see it in like an actual tense escape room environment. Does that answer your question?
Yeah, definitely.
Okay. Go ahead.
Yeah, it definitely does. I just, because Josh has to jump on too, I guess for me, I'm kind of wondering, like, how would it also work as like a mass AR experience or something like that as well?
Yeah, I haven't thought too much on like AR, but I think that this could be really neat as like just like being in an escape room and like implementing AR features to sort of add that level of immersion would be neat.
I kind of want to build on that. I other than like an AR service, I can almost see this as like a live online service where you almost franchise this out to people, where you have a standardized sort of room kit and set of actors that people could then facilitate to. And the beauty of that is that if at any given night you and a bunch of friends just want to go to an escape room, you can pretty much do that immediately. Rather than driving to a location. And I think that's a whole market that is worth looking into. So
yeah,
I think it's really cool.
I did add something. I did add like a future work thing in my paper where I commented on how it could be cool to see how much of the specific USS Cape stuff we could take out and turn this into a framework that we could give to like teachers or like companies and have them put on their put in their own information to design their own escape experience. Because really what we have is it's an app that serves like PDFs, images, videos, and HTML files. And if you have the ability to produce those things, you could really slot in whatever you want. And so I would like to, I think that could be neat to see other people using this and making this an open source framework. So,
Josh, you want to make one last quick comment before we move on to the next one?
Yeah, we've had a bunch of questions in this area, but just sort of thinking about this, the affordances of these live actor NPCs, like, are there game mechanics that you could do with a live NPC that you couldn't do with an AI or something? What does it let you do that you couldn't do with just relying on a totally automated system?
Yeah, so from a facilitation perspective, it allowed us to fudge a lot of things. So it definitely let us do some hand wavy, like, yes, I'm typing in the code now, or I'm unlocking the thing for you, or I'm going to press these buttons for you. So from like a facilitation perspective, there's a lot that you can do with people doing it. Like you can suspend the player's level of suspend the player's disbelief as you like. In one of our playtests, one of the groups, they were friends with Faith Pickles, or the actress playing Faith Pickles, and so they were like, "There's no 4-digit number code in your bathroom. I've been in your bathroom before," but we were able to sort of play that off, hand wave it away, like make it. It really like helps that behind the scenes stuff, I think, is what I'm trying to summarize.
Cool. I would love to keep talking about this. I think this was, definitely a universally loved project by everybody that participated in it. I'm sure we have lots of feedback. Maybe we can save some more questions and hopefully answers for ShowFest. But next up, we have Kimmy. And I think, so let me share my screen again.
Yep, so.
There we go. And Kimmy's got a video presentation, so I'll just get that started.
Hi everyone, I'm Kimmy. It's a pleasure to have this chance to share my thesis. I name it as The Coding Ladder, which I made as a casual puzzle game for structured programming education. Here's the first look of the game. I will give a more detailed look in later game clip video slide. In this presentation, I will walk through these 5 aspects to give you a quick overview of my thesis project. First is the background research. In that field, Blockly is my first inspiration to support my production process. It is a client-side library for the programming language JavaScript for creating block-based visual programming languages and editors. Programming robots with coded blocks and plenty of creative options provided a simple drag-and-drop interactive experience to establish coding skills. For designing coding games, Blockly is one of the ideal tools to consider. Scratch is a visual programming language developed by MIT Media Lab. It aims to help children easily create and share their own interactive digital projects, such as video games, animations, newsletters. However, it isn't friendly using a public library source, such as Scratch, to allow individual developers to work with game software such as Unity. Osmo Coding Jam is an educational game system which is able to connect with devices by using physical coding blocks and creating music beats while coding. The game making your beat come alive while learning patterns and problem solving at the same time, just like a live coding jam. In my thesis, I try to make a gamification experience to motivate non-CS background users to learn fundamental concepts in programming, or for a group of people who had a miserable time learning CS courses to regain their interest. Hence, by using the concept of blockly coding environment, this project intends to explore the use of an in-engine visual programming language for teaching programming. I had several ideas throughout the design process. Inspired by Osmo, I attempted to make a rhythm-driven game with a storytelling format. But I realized it was relatively hard for the development process as an individual thesis. Also, it may cause distractions for users to learn actual code programming concepts. To introduce my methodology, which is implemented to final production, the game is built by a series of level-based puzzles. There are 3 separate areas in the game scene: command area, program area, and puzzle map. Every block commands in the command area are scripted individually, stored in Unity scripting assets. Procedure generation level design sets game constraints to guide users reaching the goal by creating different coding structures. Also, different mapping while in different puzzle sets, increasing difficulties during the game process. In addition, the game puzzle order is followed by quiz questions order. The reason to request users to take quiz twice on both pre-game phase and post-game phase is to evaluate the results of my thesis work. Also, from the survey feedback, I will acknowledge the overall performance of these puzzle games and make future plans for later improvements. Now, let's see how actual gameplay looks like. To finish the puzzle, you only got one chance to click the play button. That's for the game balancing and playable experience. You will get a 100 score after success. In some assigned levels, there will be a new coding block types automatically come up based on level progress. Like this one, the control type of block session comes up automatically. And there's a variables. For example, here in loop function level, if you are not using loop function but reach the goal, you still lose and need to try again. Score is 50 at that point. The last level showing here will be Sandbox Level, which allows you to try every command from previous levels. Have fun on no limitation level. Due to the time limitation, I only able to show part of the game here, but I hope you enjoy that. For the evaluation method, I received 12 responses in total. I used to set users without coding background as majority, and only 2 users who learned programming to help me to critique. I also set kids and teenagers as the majority. There are only 3 college student testers join the test. The average game time for these testers was 50 minutes. I conducted a quiz for pre-game and post-game, as I said in methodology part. This is for reference data to check the effectiveness of teaching programming from my design experience. And the survey was to evaluate overall player experience to see what's good and what they complain about. As the result, 10 out of 12 testers improved their quiz scores after playing the game. Only 1 tester got a full score in both time, and 1 tester doesn't have any significant progress. I received feedback from players who took CS courses but dropped and never took again, saying that this format of learning programming process could bring them back. Most testers didn't have hard time understanding the game, and the drag and drop mechanic was easy to play. That's a good thing to know. However, the game has lots of room to develop according to feedback. Levels are relatively boring to play as a game. There was an experienced programmer express his concern about whether this type of programming format can be accepted by realistic coding works. It looks like I still need to develop more levels with more types of coding commands. If there's a player versus player mode, the game can be more challenging and fun to play. To make this game better in future, I will try to implement more levels and come with new programming concepts. Adding game elements such as obstacles in the middle of path for if-else statement puzzle, for example. And I may consider to deploy countdown timer to squeeze game time so players feel little pressure and fun to play. Here are some design ideas in future level developments. In conclusion, this is an absolutely fun experiment, and it's the first time I try to make an educational game on programming teaching topic. The procedure level design really helps to set puzzles that seem more logical. The playtesting session was interesting too. Not only me, many testers told me that they never played or seen this type of game before. It's also an experience for them to see how this method of education can help them gain new skills, such as programming. Here's my works reference. Thanks for watching.
So, so there are any questions?
I mean, I guess I have one. Like, what would be the youngest age you think that would be able to learn from this system? Because I know that, for instance, in K through 12 education, everyone's trying to figure out how to use games to teach people how to code. So does anything from the people you've been able to research with, obviously they were mostly college students, but do you see this as a game that's easy enough to start to get young people coding, especially if they have like teachers who themselves aren't coders to begin with?
Yes, so thanks. This is a really quick question. So according, like I said, in evaluation method, I used to invite like 10 teenagers and kids. So the youngest of these testers was 14 years old. So, but I guess younger people, like younger than 14, the kids younger than 14 also can learn that, because this is like pre-preparation before they learning the programming. So actual programming does not provide that kind of like work style. So I think this game is more for preparation before learning programming. Yeah.
Eric, did you have a question?
Yeah. So I was wondering if you saw the like method of teaching that you have implemented as like a potential framework that people could use to code in like for their own projects. Because I feel like if you're teaching this methodology, it could be cool for people to try to use it to go off of on their own and expand, right? So I was wondering if you gave any thought to that at all.
Yeah, exactly. So using those block commands to construct like their own project should be fun. But if there's a like this way, I design in more like systematic way. So that would be helpful for them to learn like structured programming. If they like produce their own, there will be no like so many distractions, or not like it will be out of like disorder way, I think.
Yeah.
Yeah.
I think I was just asking like if the intention was like from when they like learn programming through this tool, is it like that they're going to be using something similar to what you're using, or should they or are these skills translating to like actual programming languages?
So this is more like logic setting instead of like actual coding. So
okay.
Yeah, that's the purpose of this project. Yeah.
I think many of us here would actually say that it's actual coding.
Yeah.
So I'll disagree with Kimmy a little bit about his project in that regard, and just more generally, you know, it is teaching this Blockly system, which is integrated into a lot of other environments that support programming. So I think there could be. I think Kimmy's being maybe a little modest. I think potentially it could help people learn those other types of environments that also use Blockly, like Scratch, the most recent version. So
I thought it looked familiar.
Okay, I think that's all the time we have for questions for Kimmy.